Chapter 8.2, exercises 21 through 30. This set has to do with ellipses, finding equations of ellipses, and we're going to go through these odd-numbered problems 21, 23, 25, 27, and 29. Next exercise is 21 through 30. Find an equation in standard form for the ellipse that satisfies the given conditions. We're given a major axis length of 6 on the y-axis and a minor axis length of 4. Well, first of all, I'm going to put the standard form equation for an ellipse, and that's going to be quantity x minus h squared over a squared plus quantity y minus k squared over our b, which is our minor axis, squared, is equal to 1. And so we have a major axis length of 6. Well, what we need is the semi-major axis squared, and we're on the y-axis. So we're going to have to put this a squared underneath the y term. And so what that's going to be is our semi-major axis equals major axis divided by 2. Okay? So to get our semi-major axis, we take 6 divided by 2, which equals 3. So this is our semi-major axis. Okay, 3. So, and we know that we're on the y-axis. So let's go ahead and make a little sketch. Okay, the sketch is going to be going up 1, up 2, up 3, down 1, down 2, down 3. And I'm going to put the endpoints here at y equals 3, y equals negative 3. And our minor axis length is 4. Well, we want to have our minor axis is going to be half that. And so what I'm going to do is put to the right and to the left. And so along the x-axis we find our minor axis, and sketched out the thing's going to look something like this. Not too accurate a drawing, but kind of a football shape here, oval shape. Okay, that's not so bad. Well, that's what the thing's going to look like. Now, as far as the equation, we're going to have x squared over something plus y squared over something is equal to 1. And we're at the origin, so we're not going to have this h be anything other than 0. We won't have this k be anything other than 0. In this case, since our major axis is along the y-axis, we need to put 3 squared, or 9, underneath the y squared, and we have 2 squared, or 4, underneath the x squared. So this is going to be our equation for this ellipse. Let's go ahead and look at the next odd number problem, which is 23. In this case, we're given a different piece of information. We have a foci of plus or minus 2 and a major axis length of 10. Well, just like the last one, we know that our semi-major axis is equal to major axis over 2. And so, therefore, our semi-major axis equals 10 over 2, or 5. And I'm going to just start the sketch now here. Okay, we have, and we know that our foci are along the x-axis at plus or minus 2. I'm going to draw them in here in red. And for our major axis has to be in line with where our foci are. So if we go to 3, 4, and 5, and -3, -4, -5, we are now able to put our endpoints on our ellipse. Now the problem is, the limitation, okay, we know we have x squared over our semi-major x squared, where semi-major axis is 5, 5 squared is 25, plus we have y squared over something we don't know yet is equal to 1. And we're given a foci. Well, the Foci equation is a version really of the Pythagorean theorem, which is this: c squared equals a squared plus b squared, a squared minus b squared. And we're given plus or minus 2. Well, our focus squared is 2 squared is 4, so we have c squared is, well, we know our focus is 2 squared, which is going to be 4, is equal to a squared, which is going to be 5 squared, or 25, minus b squared. And if we subtract out 25 from both sides of this equation, we're going to have negative b squared is equal to 4 minus 25, which is negative 21. And so just coming to the right here, we have b squared is equal to 21. And so therefore b is equal to the square root of 21. Will be plus or minus. So what we have is here below the y squared, we have square root of 21 squared, right? Which is going to be equal to 21. So 21 goes right here. And then just to finish our drawing, if we go to, let's see, square root of 21 is between 4 and 5, so we go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 2, 3, -4, -5. And so our endpoints for the minor axis are going to be halfway between 4 and 5, halfway between -4 and -5. So our ellipse is going to look something like this, pretty, not too much, kind of almost circular. Okay, that's about as good as we're going to be able to do on this one. So we box this in, it's correct. Okay, next. Problem 25. We have endpoints of axes are negative, are plus or minus 4, comma 0, and plus or minus 0, comma 5. So anyway, let's go ahead and write that out. It'll be easy to make a sketch of. And our bigger numbers are along the y-axis, so we go up 5 and down 5, and then the minor axis is going to be plus or minus 4, plus 4, minus 4. So we can just sketch in our endpoints along the minor axis here, along the x-axis, and our major axis along the y-axis, and we can just sketch in our, this will be a vertically oriented ellipse. And so our equation is going to be x squared over, along, we have 4 plus or minus 4, 4 squared is 16, plus we have y squared, and we have the y is plus or minus 5, so when 5 squared is 25, is equal to 1. So that's going to be problem number 25 worked out. And we're really not asked about the foci, but if we did, or we would have c squared equals a squared plus or minus b squared. So we would have simply c squared is equal to 25 minus 16, so c squared is equal to 9. So our focus would be plus or minus 3, which will be right here where I'm putting in red, plus or minus 3, c. So there we have our foci. Okay, next on the problem, which is 27, our major axes endpoints. Okay, we have 0, comma, plus or minus 6. So again, we're talking about a y-oriented type ellipse. So we go plus 6, 2, 3, 4, 5, 6, and minus 1, 2, 3, 4, 5, 6. And we can just draw in our endpoints. And for our equation, we'll have y squared over our semi-major axis squared, which would be 6 squared or 36. And as far as our x, we have our minor axis length is 6, so our semi-minor axis is equal to 8 over 2, which equals 4. So we go 4 to the right, 4 to the left, negative 1, negative 2, negative 3, negative 4, and place these endpoints in place. So our ellipse is going to look something like this. Okay, that'll have to be good enough. So, back to our equation, we're going to have x squared over our semi-minor axis squared, which is our semi-minor axis is 4, so we're going to have 4 squared or 16. We're going to have this equal to 1. So here we are, problem number 27, worked out. Next, problem 29. We have our minor axis endpoints at 0, comma, plus or minus 4. And for that, we're going to have, okay, 1, 2, 3, 4. 4 up and 4 down, negative 1, negative 2, negative 3, negative 4. So these red points here along the x-axis, that'll be our minor axis endpoints. Our major axis length is 10, and so we need our semi-major axis. And that's going to be equal to 10 over 2, which equals 5. So we go 5 to the right, 2, 3, 4, 5, and 5 to the left, negative 1, negative 2, negative 3, 4, negative 5. And we can mark our major axis endpoints. We can sketch in using all of our endpoints along the y-axis, along the x-axis. Okay, so it'll look like this. Now we can create our equation, which is going to be x squared over our semi-major axis squared. That's going to be 5 squared or 25, plus y squared over our semi-minor axis squared. That's going to be 4 squared or 16, and that's going to be equal to 1. So we've worked through these even number problems. Our last, we worked out odd number problems. Our last even number problem, there's 30. They shouldn't be too bad. good luck on all these problems, and thanks for viewing.